Welcome to Cal Academy. In this part of the tutorial, we are going to cover set properties, and this is a part 2 of set theory. Please don't forget to subscribe, like, share, and comment. Which area we need more explanation. So here, these are the set properties, as you are seeing. We have what we call commutative property of a set. Then another one we have what we call associative property, distributive property, identity property, complement property, and then we have idempotent property. Idempotent property. Those are the 6 properties of a set. We are going to cover them systematically. Without wasting time, let's jump direct to commutative property of a set. What is the commutative property of a set? A set union is commutative. This means that A union B is the same as B union A. The same way you say B union A is the same as A union B. Then set intersections is also commutative, meaning that A intersection B is the same as B intersection A. A intersection B is the same as B intersection A. It will be better when now we shall be doing it clearly on the examples. Let's start with the first example, then let's work on now the commutative property. Let's prove the commutative property of a set. Let's prove this property, and now let A be a set of natural numbers 1, 2, 3, 4, 5. Then let B be also a natural number of the sets 3, 6, 7, and 8. Now, when you say that A union B, we mean that this comprises of all elements of A and B without repeating any element between the two sets. So here you'll see that the elements here 1, 2, 3, 4, 5, then you have 3, 6, 7, 8. So we are seeing that 3 is common in both two sets. So we only take one of the 3s, and then our union will be 1, 2, 3, 4, 5, 6, 7, 8. Those are members of our union A union B. So let's say this is the left hand side. Left hand side, we have got it is this way. So now let's now confirm on the right hand side. And in this side again, we are saying B union A. And you'll see that B union A, the members of B are 3, 6, 7, 8. Then the members of A are 1, 2, 3, 4, 5. So in the union means that we take all the elements of the both sets. We only drop the repetitive elements, whereby we don't write twice of them. We just pick one of the elements. So here it will be 3, 6, 7, 8, 1, 2. We don't pick 3 because we have already picked it in set B. So it is 3, then you take 4, 5. These are the elements in the right hand side. So we arrange it, we'll find that it is, the elements are 1, 2, 3, 4, 5, 6, 7, 8. So now you can say that these elements are the same as these other elements. So these elements are the same as these elements. They are all 1 to 8. Then it's 1 to 8. That shows that now A union B is the same as B union A. And this is what we call commutative property of a set. And that property is a union, a set union, which is a commutative property, is one of the commutative properties of a set. Then the second part, which is now we are second part which we are tackling is the intersection part. And in the intersection we are doing the same. We are also proving that whether are they the same when we shall prove that intersection B is the same as B intersection A. That is what we shall be doing in this part, so that we can prove also that in this part we shall be proving that intersection is also a commutative property, where we are saying that A intersection B is the same as B intersection A. And these are commutative property of a set. And as you know, let's use another example whereby let A be a set of alphabets A, B, C, D, E. Then let B be also a set of alphabet. You can say it is D, E, F, G. Now, when you talk of intersection, we are saying that we are looking for elements that are present in both set A and set B. So you have to check A is not present, B is not present in the other set, C is not present, D is present in the other set, E is present in the other set, D is not present, G is not present. So we say that D and E, they are present in these two sets, and this means intersection. So I can now our intersection here is D, E. These are the sets that these are the elements in these sets that intersect. And we shall see it in the next topic, where we shall be covering a Venn diagram, where we shall see that this is how where they intersect. It is this point where they share, that will be DE. This one will be A, B, C, D, E. Then D, E, F, G. So this point is what we call intersection. This point is what we call intersection. Shall cover it in the next part of sets. Now, from here now, you again, this is the left hand side. Let's now prove that the right hand side, so that you can see what shall we get also. That is B intersection A. Again, we are looking for the elements in B that are also common in A. So we shall find that the elements in B, we know that in B we have D, E, F, G. This we have in B. Then we are trying to intersect it with in A. We have A, B, C, D, E. That's what we have in A. So we are looking for which elements are common again. So we are using the same property. Okay, D is present here, then we have D here. Then E is present here, then we have E here. Then these others are not common. The remaining elements are not common, meaning that these elements, they are not intersecting. These elements, they are not intersecting. So you'll find that now in the same intersection, you'll find that we are getting again the same. That is, we are getting D and E. These are the elements that are intersecting, and this proves that now our right hand side is the same as our left hand side equals to our right hand side, and that is, we are getting that the elements are DE is the same as DE, and this one now we have proved that intersection is commutative. That is, A intersection B is the same as B intersection A. So we are done with that first property. The second property of a set, it is associative property of a set, which we say that it's an association whereby set union is associative, then again we have intersection is associative. This means that set A union set B union C is the same as A union B union C. This shows that these sets are associative. Then we can prove it as below. So let A be 1, 2, 3, 4, 5. Then let then let then let B be 3, 6, 7, 8. That is B. Then let C be 9, 8, 10. You take those ones. Now we start with now the union. When we say A union B union C, this is now our left hand side. So let's start with the brackets first. Say that B union C, what will you get? Is a union, meaning that we are taking all elements in B and C. Without taking repetitive element, that will be 3, 6, 7, 8, 9, 10. There is a repetitive element here that we want to pick it, and this element 8, which is common, intersecting between B and C. So just take 1, 8. So this is now our union of BC. Then we take that union again, take the values of A, which are 1, 2, 3, 4, 5. Then we do what we call a union operation with the one for BC, which we have found that it is 3, 6, 7, 8, 9, 10. Now from here now we pick all the, because we are talking of union, meaning all the members of the two sets or two groups of sets, and you shall find that it is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, then you shall see that we have not picked 3. We have not picked 3, and we have not picked 3 because they are common between here and here. So you just picked only 1, 3. Then these others are unique. Then you have to pick all of them. So these are right hand side. Let's also go for the left hand side, whereby we are starting with A union B union C, which is A union B. A union B, it is 1, 2, 3, 4, 5, 3, 6, 7, 8. Only there is a repetition of 3 and 3. So they just pick that A union B is 1, 2, 3, 4, 5. 5. Then we don't take the 3, the other we just take 6, 7, 8. This is now A union B. Then now C, our C is 8, 9, 10. I've just arranged it. That is our C. So now this is our C, not A, our C. So just look at, is only 8 that is repetitive here and here. So we're only picking one of it. Now these are A union B intersection A union B, then union C. So now that this is A union B, then this is C. So just pick all the elements in 2. Then you find that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So you'll find that this one and this one, they are the same. That's why we say now the left hand side is the same as right hand side. And that's now explain the associative part in regards to union of a set. Now the second part shall be explaining now the associative part in regards to intersections of a set. That's what we shall be covering in our next topic. Now let's tackle the other part, which is an intersection, whereby we are talking of A intersection B intersection C is the same as A intersection B intersection C. So find that this time let A be A B C D, that is A. Then let B B C D E, separate with commas. Then let C B E F G. Now the first operation is A. On the left hand side, the first operation is A union B, which is you'll find that it is now all the members of A and B, that is A, B, C, D, E. C and D, they are repetitive. C and D, you only pick one of them. So A, you only pick the common elements here. That is why we are saying it's an intersection. You only pick the common elements. So we are looking at saying that A, B, C, D. This one is for A. Then for B, you'll find that it is now an intersection here. Then for B, it will be C, D, E. So intersection is what that is common. Which elements are common here and common here? So we'll tell that the elements are C, D. That's the intersection of A and B. Then again, we take this intersection with intersection C. So that will be C. We have C is E, F, G. E, F, G. So we'll find that C is, members of C is E, F, G. Then you're looking for intersection between E, F, G and A intersection D, which is C, A intersection B, which is C, D. So you'll find that there are no intersecting here, and then it does an empty set. So you'll find that the intersection of A intersection B intersection C, we are getting that it is an empty set. So let's do the right hand side. Let's now confirm with the left hand side. The right hand side, that's the left hand side. Let's check the right hand side. We are saying that A intersection B intersection C. So let's start with B and C. In B and C, first of all, in B and C, members of B and C, we are only getting one member that is common, and that is C, D, E. Those are for B. Then the other one is E, F, G. So you'll find that the common element here is only E. So now A intersection B and C. So you'll find that BC intersection, we get that we are only having one element, which is E, and then in A we are having A, B, C, D. So you'll find that these two elements, these two sets, there are no common elements between them. So find that this is an empty set. That is where now they're meeting. So the intersection is an empty set. The intersection is an empty set, and then you find that now and the left hand side equals to the right hand side, and you find that the null set equals to the null set. Yeah, and that now proves that A intersection B and C equals to the same as A intersection B and C, and we have proved that one. Then our next property, we call it distributive property of a set, and we say that in distributive property you'll find that in distributive property we say that union of a set or intersection of a set is distributed over the union of a set. Intersection of a set is distributed over the union of a set. Now you get over the union, that's why A and B and B. Then the other one of union, you say that union is distributed over the intersection of a set. We say that the union of a set is distributed over the intersection of a set. The union of a set is distributed over the intersection of a set. So we can prove that one. So let's start with the one for the first one, which is union. Let's start with the union. Let's prove for the union. We see that let A be we can choose a simple number like 1 to 5 to make it simpler. 1, 2, 3, 4, 5, because we are after getting the concept. When you now get the concept, you can apply the concept in your other operations. And then B, we can say that B, we can pick 3, 6, 7, 8, and then we can pick C as 8, 9, 10. 8, 9, 10 that can be our C. Then the first operation is that now A intersection B union C. So we start with now finding the union C, and when we talk about union here, we are saying that let's start with the first one, which is intersection. We say that intersection distributes over the union, and that is now we are saying that A intersection B union C. So it will just correct. Then this part now we start with now B union C, and we say that B union C, it means that all elements in B and they are also, we take all the elements in C. We only drop the repetitive element. We just drop one of the repetitive element. So you'll find that B union C, it will be 3, 6, 7, 8, 9, 10. That is B union C. Then when you talk of A we have 1 to 5. So now we are doing an intersection. Now we'll find that which elements are now common. 1, 2, 3, 4, 5. So these are A. These are our intersection data. So we are looking for which elements are common, because these are intersections. So we are finding 3 is here and 3 is here. I think 3 is the only element that is common, and in intersection we look at the element that is both on is available or is in both on the sets, depending on when you're having 3 or 4 sets, that common element that is available or that member that is present in all the sets, that's what we are looking for, intersection. And then here we find that our intersection will be we are getting our intersection as 3, and that is our intersection, which is 3. So this means that this is the intersection of A intersection BU. So in the first operation, that is this, now we'll do the left hand side. Let's now prove on the right hand side whether we shall get the same to prove that the operation was okay. Then A intersection B, that's the first part. Then the other one is union A intersection C. So we're looking for common elements between A and B. So any common element between A and B, we'll find the common element between A and B is, common element here is only 3, A and B. The common element is 3. Then between A and C, A and C, A 1 to 5, then 8, 9, 10. So there are no common elements. So in short, this one is an empty set. So 3 union empty set, you'll find that the answer is 3, and thus proves that now the left hand side is the same as the right hand side. So we are done with that. Then again, let's look at the union is distributed again over the intersection. We're talking about the union. So A union into bracket B and B intersection C, not N, sorry. So we'll find that A, we start with B and C. So we're looking for which elements are present in B and C. So you come just here, B and C, the element that is present. We only find that 8 is the element that is present. Then we pick 8. Then elements in A, then so we'll see that as we continue, this other part we found that it is this one. Then we'll see that now this is the left hand side of this operation, and we said that A union B into bracket B intersection C equals that A union B into bracket intersection A union C. This that's union distributes over intersection. So this other part we have found that these are the elements. Now we are in this part whereby we are taking that A union B shall just take all the elements of A and then all the elements of B. And the elements of B are 3, 6, 7. And then because of repetition, we're taking 3, 6, 7, 8. Then that intersection again, A union C. Now we get the A union C with just all the elements of A. Then the elements of C, it's 8, 9, 10. Then what intersect between the two? We find that is 1 to 5 that intersect. Then which element again? It is 8. 8 only. 9, 10, and 7, they are not intersecting anywhere. So we find that this is, and this shows now the left hand side equals to the right hand side. And this shows that now 1, 2, 3, 4, 5, 8 is the same as 1, 2, 3, 4, 5, 8. And then we have prove the what we call the distributive property of a set.